Hello and welcome back to ovesen.net. Today I'm taking a look at this machine. It's Texas Instruments TI99. I'm actually busy working on this Commodore 128 motherboard, and I can't really find what's the matter with it. It's black screen, so I need a break from that now, and that's why I'm taking a look at this machine. And I don't know if it's working or not. I haven't even tested it, so it's gonna be exciting. This machine is totally unknown territory for me. I have never even seen one before, and it's an American model. It has American 110 volt power supply, so I can plug it directly into my socket here. The Texas Instruments TI99 was released in June 1981 in the United States. It has a CPU called TMS9900 that runs at 3 MHz, and it is actually a 16-bit CPU. However, the architecture of the machine prevents it from using the 16-bit CPU at its full potential. The machine has 16 kilobytes of memory, and it has a graphics chip called TMS9918A that is capable of 16 colors in different resolutions. As an operating system, it runs TI Basic, which is based on an extended version of the Dartmouth Basic. Anyway, I'm gonna do a test, and then I'm gonna do a full restoration, and if I have the capacitors needed, I'm gonna replace the electrolytes, and then maybe I'm gonna take a look at some games, see if I can find a way to run games on this one. This is the power supply. It's a brick. It says 120 volt AC and 40 watts. This uses 110 volts, and here in Norway we have 230 volts and 50 hertz. So this can't be used here. However, I have a step-down converter. This is the step-down converter. It is a transformer that transforms 230 volts AC down to 110 volts AC. So I'm connecting the power supply for the machine, and I'm gonna measure the output. So it makes a humming sound, not uncommon for these kind of old power supplies. You could of course replace this with a modern alternative with a switching power supply. Anyway, I'm gonna measure the output voltage just to be sure that it's not over voltage, and that might damage the machine. Zooming in on the power supply, it says that the pins 1 and 2 should have 18 volts AC, and pins 2 and 4 should have 8.5 volts AC. That's strange output values. Alright, let's measure. I set the multimeter on 20 volts AC. Alright, it's pretty accurate. It's exactly 18 volts. And then on pin 2 and 4 should be 8.5 volts. Yeah, dead on that one too. But strangely, there's not anything mentioned about pin 3 here. Alright, when I take a closer look, there's nothing inside the hole marked as pin 3, so not connected. Alright, that means that this power supply is safe to use, and I'm gonna hook it up to the machine, and then I'm gonna plug it in and see if we can can get something on my screen. No bang this time. If you saw my unboxing video where I shown this machine once before, you saw that I had a little bit of poof and a magic smoke coming out of one other machine. No, I don't know how to hook this up to a screen, but the video output port is this 5-pin DIN connector, and this actually fits the cable I have used on my VIC 20. So I'm testing that one to make sure that I don't send any high voltage into my television. I'm gonna measure each of the cables from the output of the machine. So it seems to be yeah, low voltages. I'm gonna test the AC too, just to make sure. It's 0 everything, almost. Yeah. Alright, so then I think it's safe to plug it into my television. Time to test if there is life in this machine, and here's the power switch. Hey! Excellent! That's a pretty good picture quality and lots of colors on this one. Ready, press any key to begin. Copyright 1981. Press 1 for TI Basic. And as always, make a small basic program. Print. How do you delete button? Where's the delete button? I had to restart. I couldn't figure out how to delete a character, so let me try once more. 10, print, hello. 20, go to 10. Run. All right. All right, that was the initial test, and now let's continue with the restoration. I'm gonna open the case and take a look inside. Exciting. How do we open this machine? It's always a good question. It seems to be stuck on this power switch. So, okay, you can just pull it out like this. Then we are able to remove the bottom cover. Strange thing this, some kind of shield and some kind of rubber foot, or what is it? I don't know. So I'm continuing the disassembly and removing the other parts so that I can free the complete case and clean it. So this is the power supply board, and big capacitor, 3300 microfarad. Oh man, this is heavily shielded. Metal plates around the whole motherboard. Disconnect the keyboard. It's this cable here. Then I can remove the keyboard. This is one heavy keyboard. It's really massive. It's a completely different design than what I'm used to from Commodore machines. The case is quite clean on the inside, so there's no need for any special treatment or cleaning. I'm just gonna spray with some isopropanol and just wipe off. Using a microfiber cloth, nice and clean. The upper case aluminium finish here has some scratches, but I guess that's normal for this kind of old machine. It's very little scratches for the age. I don't know if there's some method I can use to polish it or something to make it go away. Maybe I'll check it out. The motherboard, it has this expansion port that just can be removed like this, and then we have to remove the metal shield, and it's a really sturdy design. It has these bolts and with nuts that goes through the whole thing. So just gonna remove this clamp. I don't know why they put this one here. It seems to have no purpose other than to hold the shield in place. All right, that's the motherboard. The motherboard seems to be in a good condition, not dirty, and nothing seems to have happened to this one. It's a bit of a strange construction. What are these long white things here that are soldered to the board? What is it? Is it some kind of electronic component? If anyone knows what they are, please comment below the video. I don't know anything about the architecture of this machine, but I see here it's produced. This chip is produced in December 1982. So that's almost 40 years ago. Since all the caps are axial capacitors, I don't have a stock of those because those are more unusual types, and I have to order them. So I have made a note of what I need to order, and this is the list with the count, the number of capacitors at the side. The PCBs are extremely clean, so there's almost nothing to do there. I'm just gonna clean off the thermal compound paste and replace it with new. Alrighty, the capacitors came in the mail today from DigiKey, and I ordered good brands, Nishikon. So let's go on with the recapping. I'm starting with the power supply, and it has 6 capacitors, and they're listed here, so I just desolder them all first. I have heated up my desoldering station and it's ready to desolder. So they came loose pretty well, except for this one here. I'll need to do another round. Then I use a little bit of solder wick just to clean up the pads. Oops, it's hot. I'll desolder the rest of the capacitors and gonna remove them and then ready to solder in the new ones. As always, important to get the correct polarity, so you need to make sure that the minus is pointing to the correct pad, and these are marked with plus here. Little bit of flux. Then I'm ready to solder in the 3 first capacitors. Just a little touch up afterwards because this was not a good solder point, because there's a large ground plane here. It needs a lot of heat. That was all the capacitors replaced, and I'm just gonna clean the board a bit before moving on to the motherboard. So I'm using isopropanol alcohol to clean everything. Then the motherboard itself, and it's not that many caps, it's 9 caps, and mostly 22 microfarad, then a few hundred, and finally 116 microfarad. If you recap a board like this, then remember to take a photo of the complete board with all the different cap values. In this case, I'm gonna desolder the 3 100 microfarad capacitors first in order to not confuse any values. So these capacitors are not marked on the board in any way, so you need to make sure you get the right polarity. A little bit of smoky soldering, and the smoke always goes into my face. Alright, on with the rest. finally the last one, 22 microfarad, positive pointing upwards, 22 microfarad, positive pointing upwards. Of course, I mean the negative pointing upwards. The arrow points where the negative side is, and that's a minus. And I always try to bend the legs in such a way that the marking, the value and the polarity shows up and not down. I hate it when they are showing the value downwards and you have to desolder them to find the correct value. That was the soldering. I think that went smooth, and now I'm gonna clean the whole backside of the board with some isopropanol and give it a good rub with my toothbrush. Then I spray once more, and then I just push some tissue paper against it to lift up all the dirt. That was the recapping of the boards, and besides that there's nothing much to do on these boards except maybe a little bit of electronic cleaner onto the contacts. So I'm using a little bit on every contact and into the power switch. I'm gonna assemble the machine now. Before I do that, I've just put a little bit of thermal compound onto these metal bars that are meant for cooling. Let's see if I can fit this together. Then there's these bolts that need to find their place. I'm not sure if I remember exactly. Here's the smallest of the bolts. It actually has a washer too. And this long bolt goes in the opposite direction and through the whole board. Damn. Of course, to assemble the machine, it's the other way around. You need the top cover first, and then you put the motherboard and everything inside that. The keyboard is so clean and in such a good state that there's nothing I need to do with that. Then the connection from the keyboard is under here. This plastic piece here is part of the power switch, and it's not obvious where it's going, but it's supposed to go here. Then I'm gonna screw on the keyboard and the motherboard, and then we're good to go with the power supply. Time to assemble the power supply, and it goes here. Like that, and then we have to figure out how to get the power switch aligned. So I just put the little standoff into the hole here, and then these two holes, screw holes, should align, and this one should be where the power switch is. Yeah, I think that's okay. Finally, in the back cover of the case. Oh, I almost forgot this one. I forgot to put the cartridge extension in place on the other side, so I have to remove this one and put it in place. Luckily that was only 3 screws to get this loose, and then I'm just gonna push this extension down like that, and then try to refit the motherboard into the case. A little bit of wiggling should do. That's a perfect fit, so I'm just gonna screw down the back case, and then we're ready to test this machine. Final piece of the puzzle, the power switch. Okay, I have hooked up the machine, and I'm ready to test, so it's a moment of truth. Hopefully nothing will explode, or no smoke will rise. Turning on. Alright, excellent. Hey. Nice. And I actually think the picture looks better than before. I don't know, maybe it's just some imagination, but I think it looks crisper than it was. Anyway, that was the hardware, and it was recapping. So next, let's check out some software. To load software on this machine, I either need some cartridge or a cassette tape solution, and I don't have any cartridges, and also I don't have a cassette recorder that I can use, so I thought I'll use the method of using an iPad or computer as a cassette drive mechanism. This is the cassette port. It's a 9-pin D-sub connector, and same as most joysticks are using. So, I thought I'll try and make a cable for this that I can use as some way of loading software onto this machine. To make the cable, I'm gonna use this cable here from an old broken joystick. Perfect. Hopefully this will have the necessary pins in order for me to connect to the machine as a cassette contact. This is the pinout for a cassette connector, and there's a lot of output pins. However, I think I only need the 2 input pins, which are pin 9 and 8. Because I'm not interested in trying to write anything to a cassette, only read data. Unfortunately, pin 9 is not connected to anything, or it's just an empty hole here, so I can't use this one, or I have to find some makeshift solution to use it anyway. Anyway, I measured pin 8 to be this black wire, so I'm gonna make just a temporary makeshift cable here that I can test with. I know you can buy this ready-made cables online, so I'll do that later for a more permanent solution. But for now I'm just making this this one here. That's the ground. Hopefully it will be a good connection, or maybe not. That was pin 8. Now for pin 9 I'm just gonna use this thin wire, and I just put it inside the empty hole like this. Then I just tape it like this to keep it steady. Then the other end on the phono cable, it's and wind it around the tip like this, and then some tape. Yeah, this is a very professionally made cable. I think I'll sell these on eBay. So if I can fit this, then I think the connection will be good. So let me try. Push it in. Yeah, that seems to work. Excellent. That's the cable already. My plan now is to use my iPad mini and find some audio file as a cassette file and play it off onto the computer just to simulate a real cassette recorder. Thanks to the internet, I found this archive called Favorite Games, and it's around 50 different games for the TI99. And those are WAV files that can be played off an iPad, and I uploaded the files to my OneDrive so that I can easily play them back on an iPad. How do I load some software onto this machine via cassette? Every BASIC has different ways of loading. So in this case I did some research, and the command for loading from cassette is OLD CS1 in uppercase. Alright, it says rewind cassette tape CS1, then press enter. So I already did rewind, then press play. So now I just take something small here, final front, and start to play from the iPad. It says reading. By the way, I have the volume on the iPad to max. Hey, it actually worked. Fantastic. And to be honest, this is the first try. Press cassette stop, then press enter. All right. And now it's just to type run. Hey, hey! All right. So, how do I control the ship? You have lost. The aliens have won. Ah, bummer. I guess this is a basic program. Let's try a list just to peek. Yeah. This is the program. This was really exciting. I have used this method for loading programs onto old computers before, but then I always struggled a lot to get the correct signal level and things like that. And even I have failed using my iPad. I had to use a computer one time, but this was a success at first try. Anyway, let's try another one. It's really strange command to load from cassette, OLD. It's probably a shortcut for something. Okay, so what should I try now? Let's try alpine skiing. All right, let's try a little skiing. Press enter. Arrows to go right or left. Press spacebar to go straight ahead. And I'm a beginner. All right, doesn't seem to respond. Arrows, yeah. What is arrows? There's a lot of arrows on this keyboard. None of them are working. Nah, that didn't work. Let me try something else. All right, Type Invaders, this one is called. I didn't get the point of that game, but who cares? Not the best of games I found. I don't know if it's even possible to load the machine code games from cassette. These are all basic games, the ones I found. Alright, that's it for this video. Exciting machine, Texas Instruments TI99. Been fun. Hope you enjoyed this video, and hope you will subscribe to my channel to see more videos coming. So thanks and bye bye.